Peas, beans, and clover are among the 18,000 species in the pea family. Most species in this family, including these three, are known as nitrogen fixers. They increase the level of nitrogen in the soil, which plants need to produce protein so they can grow, and chlorophyll so they can photosynthesize. One way to use this in the garden is to interplant nitrogen fixers with other plants that need a lot of nitrogen. Or you could plant a nitrogen-fixing cover crop like clover for fertile soil next year. Okay, this can be useful, but doesn't nitrogen fertilizer do the same thing but more conveniently? Why bother with this nitrogen fixation thing? Understanding this requires us to understand how nitrogen fixation works, which in turn requires us to understand the broader nitrogen cycle. So let's start with the big picture. Nitrogen makes up 78% of the Earth's atmosphere by volume. But most of this nitrogen takes the form of two nitrogen atoms strongly bonded together, which isn't very reactive and is useless to plants. For it to become plant available, we need the help of bacteria. Various species of bacteria eat atmospheric nitrogen and poop out ammonium. This gets eaten by other kinds of bacteria, which poop out nitrite, which gets eaten by yet another kind of bacteria, which poops out nitrate. All of these forms of nitrogen are available for plants, especially nitrate, which is the easiest for plants to use. Plants can take this up directly if it is near their roots, but they most often rely on strands of fungi that attach to their roots and bring nutrients to them in exchange for the sugars and carbohydrates the plant roots exude. Dead plant material is also rich in nitrogen and gets brought down with the help of worms, whose poop is a delicacy among nitrifying bacteria. Some of the ways nitrogen exits the soil is when the crop is harvested, when water carries it away, or when it becomes gaseous and returns to the atmosphere. Or if the soil lacks oxygen, different anaerobic bacteria grow, which convert nitrates back into atmospheric nitrogen. Notice that these things only happen with loose nitrogen in the soil, not with nitrogen inside organisms. Okay, so we know that the nitrogen cycle depends heavily on life in the soil. Without them, the plants would be quite sad. But you may have noticed, if the fixation process is done by bacteria, where do nitrogen-fixing plants fit into this? Believe it or not, nitrogen-fixing plants don't fix nitrogen. Rather, they create habitat for the bacteria that do. The roots of this clover plant have little nodules that house huge amounts of nitrogen-fixing bacteria. The ammonium that these bacteria create slowly releases into the soil for neighboring plants and microorganisms to use. When the plant dies, the bacteria disperse into the soil, resulting in an abundance of bacterial allies for future plants' nitrogen needs. You know how earlier I said that water can carry soil nitrogen away? This nitrogen ends up in rivers, which can disrupt the ecosystem by enabling algae to dominate. But remember, this only happens to loose nitrogen in the soil, and not to nitrogen embedded in organisms. And fertilizer adds pure nitrogen without the organisms. So when it rains, huge amounts of it run off and pollute the water. Loose nitrogen molecules are also much more prone to volatilization, releasing huge amounts of nitrous oxide, a potent greenhouse gas, into the atmosphere. But that's not all. Such quantities of pure nitrogen irritate earthworms, which end up dying or leaving. It disrupts the helpful fungus on plant roots and changes the soil pH, making it inhospitable to bacteria. In short, it kills the soil. When the nitrogen all gets used up or washes away, the organisms aren't there to help the plants get more. So now you have to add more fertilizer, which worsens the problem. And these organisms did much more than just supply nitrogen. The root fungi also brought up important minerals for the plants. And now that they're gone, mineral fertilizer must also be used. Instead of working with this self-sustaining web of organisms freely sharing nutrients, we have to spend more money to add loads of fertilizer to dead soil, poisoning the water and contributing to climate change. Considering the inability of dead soil to supply plants with nutrients, it's no wonder that throughout the last century, vegetables have been steadily declining in nutritional value. Healthy food requires healthy soil. So if the soil around you is rich and alive, try to keep it that way. But if, like most of us, the soil around you is dead or dying, nitrogen fixers can help to add a little more life so that someday our tiny allies under our feet will come back.